What is an intuition pump? An intuition pump is a term coined by philosopher Daniel Dennett. It refers to a hypothetical scenario, analogy, or thought experiment designed to evoke intuitive responses that support a particular philosophical position. Core features: simplifies complexity, strips down a problem to its intuitive core, guides attention, highlights certain features while downplaying others, frames the debate, often subtly nudges the audience toward a conclusion, can be rhetorical, sometimes used more to persuade than to clarify. Examples: the Chinese room Searle pumps intuitions against strong AI. Mary the color scientist, Jackson, pumps intuitions about qualia and physicalism. The experience machine Nozick pumps intuitions against hedonism. How it affects truth tracking. Intuition pumps can either enhance or distort our ability to track truth, depending on how they are constructed and used. Helpful when they clarify structure, making abstract ideas more graspable. They reveal hidden assumptions, exposing what is taken for granted. They test coherence, stress testing a worldview under imagined conditions. Harmful when they smuggle bias, embedding assumptions that skew intuitions. They oversimplify, ignoring relevant complexity or thresholds. They mislead by analogy, suggesting false equivalence between domains. You can treat intuition pumps as operational tools, not just rhetorical devices. You might deconstruct a pump into its modular assumptions, reframe it to expose hidden worldview friction zones, convert it into a dynamic system model to test robustness across contexts. Dynamic system model example for testing robustness across contexts. Example in argument: banning single-use plastics reduces ocean pollution, all else equal. Instead of freezing variables with all else equal, convert it into a dynamic system that lets key drivers move and interact. Regarding means and method of single-use plastics, ocean pollution contributions to best track the truth of implementing a ban. This ensures a substitute to plastics doesn't end up compromising the conditions of the arguments such that things are not equal. What all else equal claims to do. It is meant to isolate a single variable for analysis. If X were true and all else remained equal, would Y follow? This is useful for counterfactual reasoning, causal inference, or moral comparison. How it unfairly loads the hypothetical. All else equal can smuggle assumptions that ignore threshold effects. Some systems flip behavior when a variable crosses a boundary. Erase systemic entanglements. Moral or causal variables are often interdependent. Suppress emotional salience. It can neuter the intuitive force of real-world consequences. Bias the framing. It can make one option seem cleaner or more plausible than it really is. Example: if we could clone a person and all else were equal, would they have the same rights? This presumes social attitudes don't shift. Legal systems adapt seamlessly. No psychological or identity complications arise. In reality, cloning introduces ripple effects on identity, kinship, legal precedent, and emotional framing. All else equal unfairly sanitizes the scenario. You can diagnose and diffuse unfair all else equal loading by mapping suppressed variables. What is being held constant that should not be? Testing threshold sensitivity. Does the system behave differently near a boundary? Reintroducing entanglements. What feedback loops or dependencies are being ignored? Reframing the analogy. Can you build a more honest pump that preserves complexity? Summary. All else equal is a counterfactual shortcut that pretends to freeze a complex web of causal, normative, and psychological variables so we can inspect one factor in isolation. That simplification can be epistemically useful, but it also systematically hides dependencies, thresholds, and feedbacks, thereby biasing intuitions and conclusions unless we explicitly model what was frozen and why. Mechanisms by which it loads hypotheticals. Hidden ceteris paribus assumptions. It silently selects which variables are relevant and which are not, privileging some causal stories and neglecting others. Threshold erasure. Nonlinear effects or tipping points are removed, so conclusions that only hold below or above a threshold look universal. Network decoupling. Feedback loops, institutional responses, and social signaling are treated as inert, which erases secondary consequences. Emotion and salience flattening. Emotional, identity, and experiential features that shift judgment are treated as irrelevant, making morally charged outcomes appear neutral. Analogy tightening. It forces a tighter mapping between domains than is warranted, producing false symmetry and misleading transfer of inference. Let's work out a few examples that expose different loadings. The first, bioethics example. Statement: if we could make a person immortal and all else were equal, should we do it? Loading erases population dynamics, resource thresholds, legal political responses, and identity drift that would follow immortality. Therefore, moral judgments based on this sanitized case misrepresent real-world trade-offs. Economic policy example. If taxes on X rose and all else were equal, revenue would increase. Loading erases behavioral responses, tax avoidance, market substitution, and threshold effects that often invert simple predictions. Now, before we move forward, let's review the contention of an intuition pump here, which demands call-out. Why calling out the held equal variables matters. All else equal is not neutral, it's a selective freeze frame. By asking what exactly is being held equal, you reveal hidden assumptions. What is being treated as inert or irrelevant? Expose moral loadings. Which emotional, institutional, or systemic variables are being suppressed? Test robustness. Does the conclusion still hold when those variables are allowed to move? These clarifying questions, among others, ensure that the speaker must justify their freeze-frame choices, particularly the principle or principle conjunct to be tested, rather than relying on shadowboxing argumentation that is not being postulated. This helps avoid talking past each other, ensuring semantics are not the dispute of argument acceptance. This transforms the debate from intuition-driven to structure-aware. Operational strategy. How to request the call-out. Here's a modular approach you can use in live debate or written critique. Step 1. Identify the frozen frame. You've said all else equal. Can you specify which variables you're holding constant? Step 2. Probe for thresholds and entanglements. Are any of those variables known to have tipping points or feedback loops with the one you are changing? Step 3. Reintroduce suppressed dynamics. If we let X vary, say institutional response or emotional salience, how does that affect the outcome? Step 4. Stress test the pump. Would your conclusion still hold if Y were allowed to shift in response to the change? Example. AI writes hypothetical. If an AI had conscious experiences and all else were equal, it should have rights. Call-out response. What is being held equal? Legal systems, social attitudes, economic incentives, verification methods, knowledge of their intrinsic status. Are any of these thresholds sensitive? Yes, degrees of harm and institutional legitimacy can flip with perceived AI personhood. What happens if we let them vary? Maybe they are not of the same kind. Rights attribution may trigger backlash, redesign, or moral inflation. The setup, a tension between ontology and potential. Create a world where a person is currently brain dead or decomposing, that is, ontologically dead, but there exists magic dust that can revive them, that is, potentially alive. The question is, does this person have intrinsic value? And the trap is, if you say yes, you are attributing intrinsic value to a corpse, which feels absurd. If you say no, you are denying intrinsic value to a being who can fully return to life, which also feels absurd. This is a value bifurcation. The subject is simultaneously ontologically null and potentially full, and any binary answer feels wrong. Why? It feels like a reductio. It's not a classic logical contradiction, but it forces a collapse in the concept of intrinsic value by exposing temporal ambiguity. Is value indexed to current state or future potential? Revealing framing instability. The same entity is being modeled as both dead and revivable. Triggering moral dissonance. Our intuitions about corpses and persons clash. This is a semantic overload. The term intrinsic value can't cleanly apply across both frames without breaking. What this reveals about intrinsic value. The scenario interrogates the coherence of intrinsic value as a temporally stable property. It suggests intrinsic value might be relational to time and potential, not just present state. Or intrinsic value might be a heuristic for expected future states, not a metaphysical constant. Or we need to split the concept, perhaps intrinsic dignity versus functional moral status. Philosophical moves you can make. Demand a disambiguation. Are we talking about value now or value across possible futures? 2. Introduce a third category, dormant value or latent personhood to capture the in-between. 3. Reframe the question, what obligations do we have to beings with revivable personhood? 4. Use a clash matrix. Map how different ethical frameworks, deontology, consequentialism, virtue ethics, personhood theory, respond to the scenario. What is a category error? A category error happens when something is placed into the wrong logical or ontological category, when we treat it as if it belongs to a type of thing it doesn't. Classic example. The university is in the same category as its buildings. Ryle misclassifies an institution as a physical object. Category errors in hypotheticals. Hypotheticals often smuggle category errors to make their intuitions feel persuasive. Corpse versus personhood. Treating a decomposing body as if it were still a candidate for intrinsic value in the same way as a living person. The category error is between biological matter and moral subject. Potential versus actual. Treating potential personhood, such as a revival corpse, embryo, or artificial intelligence in training, as if it were identical to actual personhood. The error is collapsing latent capacity into present actuality. Instrumental versus intrinsic value. Confusing the value of something as a means, revivable matter, medical resource, with its value as an end, a conscious subject. The error is conflating categories of value. State versus process. Treating death as a static state when the hypothetical introduces revivability as a dynamic process. The error is miscategorizing a reversible condition as an absolute. How category errors amplify obfuscation. Category errors are the engine of obfuscation. They flatten distinctions that matter, corpse versus person. They misdirect intuitions by forcing us to apply moral categories where they do not belong. They create false dilemmas, yes or no answers that both look absurd. They mask thresholds, alive, dead, revivable, by treating them as one category. Diagnostic questions for category errors. When facing a loaded hypothetical, what category is the subject being placed in? Corpse, person, potential person, resource. 2. Is that category appropriate to its current state? 3. Is the hypothetical collapsing categories that should remain distinct? 4. Would the intuition change if we reclassified the subject correctly? Applied to your magic dust scenario. Category error, treating a corpse as a person intrinsic value or treating a revivable person as a corpse no value. Both answers feel absurd because the hypothetical forces us to miscategorize the entity. Fix. Introduce a third category, latent personhood or revivable subject, to dissolve the reductio. In short, obfuscation in hypotheticals often relies on hidden category errors. By demanding a call-out of what is being held equal and clarifying the categories in play, you can expose where the intuition pump is misleading. There have been many attempts, but designing appropriate categories of existence, one is Aristotle's 10 categories. Here's a clear breakdown of each. Substance, ousia, the fundamental thing that exists independently. Example, a person, a horse, a tree. 2. Quantity, poson, refers to measurable aspects. Example, 2 meters long, 3 apples. 3. Quality, poion, describes characteristics or attributes. Example, red, honest, round. 4. Relation, pros tie, how something is connected to another. Example, larger than father of. 5. Place, pew, the location of a thing. In the marketplace, at home. 6. Time, pot, when something occurs. Example, yesterday at noon. 7. Position, kisti, the arrangement or posture. Example, sitting, lying down. 8. State, etienne, a condition or possession. Example, armed, wearing shoes. 9. Action, poiein, what something does. Example, cutting, running. 10. Passion, paschain, what something undergoes. Example, being cut, being burned. Why they matter. Aristotle's categories are not just labels, they are attempts to map the fundamental modes of being and predication. They became central to medieval scholastic philosophy, influencing thinkers like Thomas Aquinas. Later philosophers like Kant reimagined categories as structures of thought rather than being, showing how flexible and contested this framework is. Robert Rosen's closed systems are his way of modeling living organisms as self-sustaining networks, and he used category theory to formalize this idea. In his work, especially the development of MR systems, metabolism repair systems, Rosen argued that the defining feature of life is that it is closed to efficient causation, meaning that every process needed to sustain the organism is generated internally by the system itself, rather than relying on external efficient causes. Rosen's closed systems. Closure to efficient causation. In Rosen's view, a living system is not just a machine driven by external inputs. Instead, it contains within itself the causal processes that maintain and regenerate its own components. MR systems. His formal models of cells show metabolism, M producing components, and repair R processes regenerating the metabolic machinery itself. This recursive closure is what makes the system alive. Contrast with open systems. Traditional mechanistic biology often treats organisms as open systems, exchanging matter and energy with the environment. Rosen's closure emphasizes organizational autonomy. Life is defined by its relational structure, not just by material flows. Categories and category theory. Rosen was one of the first to apply category theory to biology description systems. Category theory provides a language of objects and morphisms, which are relations rather than focusing on equations or states. For Rosen, this allowed him to model biological systems relationally, not as collections of parts, but as networks of functions and entailments. Key insight. Category theory captures the organization of living systems, showing how processes map onto each other in a closed loop. This avoids reductionism and highlights the autonomy of life. Why it matters. Rosen's closed systems challenge the mechanistic view of biology by insisting that life cannot be fully explained by reduction to physics and chemistry. His categorical approach reframes biology as a science of relations and organization, not just of material substrates. This has influenced fields like theoretical biology, systems theory, and even semiotics, where researchers explore how meaning and function emerge in self-organizing systems. Big picture. Robert Rosen's work shows how closure and category theory dissolve category errors in biology. Instead of misclassifying organisms as machines or open systems, he reframes them as relationally closed networks. This aligns with your interest in threshold maps and clash matrices. His models explicitly mark the threshold between mere mechanism and living autonomy. Big takeaway. Across all these threads, the lesson is, philosophical hypotheticals often mislead when they obfuscate variables or commit category errors at thresholds. Truth tracking requires exposing what's held equal, clarifying categories, and modeling liminal states rather than forcing binaries.